Okay, let's start. Welcome back from spring break. Let me minimize this window. All right. Yeah, so welcome back. I hope that you have a good break, or take a good rest during your spring break, and now you're amped to get back to new assignments. So we're gonna have this format string assignment released just half an hour ago, I think. Yeah, it's like very recent. And the deadline will be 2 weeks after, so it's like it's gonna be March 28th, Tuesday again, so it's the end of the next Tuesday. It's similar to what we did, like infrastructure wise. You're still gonna have a use Dojo, using the modules over there. We have a new modules called format string module, and there are 8 challenges there. So all you need to do just to finish those challenge and get the score. Now I'm just looking at it. I realized I didn't put a link here, but if you have the Discord, I think I announced it somewhere. Right. Okay, yeah, so I'm just showing the screen real quick. So there are 8 levels here. It's good that we already have students working on the challenges right now. Good job. So today, this is more of a Q&A session, but also, I would like to help you guys with the assignment in the sense that I think challenge level 2 might be, a hard one. It could be like a leap comparing to challenge level 1. So challenge level 1, it's similar to the lab that we did 2 weeks ago. But then challenge level 2 will contain more content. So my suggestion for you guys, since I just released and you probably haven't had the time to look into the challenges yet, right? So let's use level 2 as a kind of a demo for today's lecture. Okay, so it's gonna be similar as what we did for the lab. Now, can you please look into level 2, work on that challenge? And actually, if you look at challenge to level 2, it should be that all you guys have the same challenge. So comparing to the other levels where you have unique challenges for yourself, level 2 is a uniform challenge that everyone has the same one. Okay, so let's work on level 2 together. I will probably give you guys 15 minutes to, set up the environment if you haven't had it yet, and also work on level 2 briefly, and then we can work on level 2 together. All right. Sorry, I just realized that I was muting myself from Zoom. So let me say that again, just to Zoom people real quick. We're talking about this vulnerability, and this vulnerability is in function func, and specifically at line 82 because of printf, and then because of the variable layout.buff can be controlled by user's input. And now we are about to think about how to, take advantage of this vulnerability. And by the way, thank you people from Zoom for reminding me that I mute myself. Awesome. Cool. Okay, now I'm going to continue. So if you remember last time, in last week, what we do for format string vulnerability is that we figured out the wing function's address, right? And then we overwrite the GOT table, right? The GOT, the GOT table. We overwrite one entry, one item in a GOT table, replace that with wing function, right? So this is what we did last time. So we found the GOT table is somewhere that we can overwrite, and then we replace that with the function of wing. Okay, so the first thing that you may ask yourself is that, can we do this again for this challenge, right? However, this is not the case, unfortunately, and there are a couple of reasons. One is that what I'm doing right now. Okay, here we go. One is that if you run it, this challenge, it will tell you that something, right? Yeah, like, which means that this challenge has full rule enabled, which means that you cannot overwrite the GOT table, right? So that means that this time you cannot really overwrite the GOT table with the wing function, specifically if you use checksec. Kill this process and then do checksec. It's very slow on my end. I did type, but it doesn't respond. One second. Oh, okay. Good. Now it responds. Checksec, right? And this challenge, you will be able to see all the security defense that has been turned on, right? I mean, you know about this command for a long time ago. So you know that it tells you that, okay, it has already had full railroad, and this means that, and also Pi enabled, right? So this means that every time that you run this program, the actual function address, like the function address, will be changed every time they run it because of SLR and because of this Pi enabled option, right? Good. Okay, cool. So this means that if you still want to call function wing, in any case, in any means, the address of function wing will be changed over time, every time that you run it. So you want to figure out a way to leak it, right? So think about how you can leak function wing based on this program, taking advantage of this format string vulnerability, okay? And if you remember, 2 weeks ago, when we talked about format string, we mentioned that using format string, you can do arbitrary read, right? Then the question here for you is that, can you come up with a way that you use this arbitrary read to get, something, some information that can be relevant to function, wing, so that you can infer function wings, runtime address. Does it make sense on a high level? Good, good. Okay, cool. Okay, so now let's think about this. How, like, if now we're thinking about constructing the arbitrary read, like, let's suppose that we already know there is arbitrary read. Now let's just first figure it out. If we're going to take advantage of this arbitrary read, where do we want to read, right? And then we think about, okay, how are we going to implement this using format string vulnerability. Okay, so let's first figure it out. If we're going to do arbitrary read, where do we want to read from so that we can get some information relevant to function, function win? Okay. Does anyone have any idea? Yes. That's right. We can try to read the return address because we know that the return address is stored on stack, right? And then arbitrary read in this case can help us to read like anywhere on the stack, as long as we specify the right, like exactly right location, right? Like we say we specify like the 10th or the like whatever index of the argument using format string so that we can find where the return address was saved, and then we can read that out. And of course, the return address is somewhere on the code segment, right? It's somewhere related to, in this case, it's function main, because function func, when it returns, will go back to function main. But then in that case, we will know one instruction, a runtime instruction of function main, and we can use that to infer the current runtime function, address of function win. Does this piece of this part make sense? Do you want me to explain this again? Yes, good. And feel free to tell me that, Tiffany, what you're saying doesn't make sense to me. I won't take it in person. That's not a problem at all. Okay, so I'm gonna draw the stack, and Zoom people, I will try my best. Hopefully you can see my whiteboard. But yeah, I will, hopefully this works. If not, I guess maybe some of you guys currently like here, if you can take a picture of it later on and then post it on Discord, I will very much appreciate it. Okay. All right. So let's do this. So we have the entire stack, right? I'm going to draw the stack. Okay. Like we've done this for many times. So this is low address and this is high address, right? And then when function func is being called, right? We have a function phrase. Let's say this is RSP, and then this is somewhere, where RBP is pointing to. So this is like the stack frame for function func, right? Okay. And we know that the saved RIP will be somewhere here, right? This is the saved RIP. And we know that by the time that function func was called, it should be that main calls func, right? So that we know that this address, this content, the content that stores here, which is the saved RIP, should be somewhere in main, right? Because this is the return after function func goes back. Like after function func is finished, we will go back to somewhere in the main function, right? So we know that this should be an instruction in main. Okay, cool. And also we know that inside function func, we're going to use printf, right? We call that printf, which has the format string vulnerability. So the buffer, like the format f, the buffer is somewhere on the stack, right? I'm going to just draw this somewhere. Maybe this is the place of the format string. So what you want to do is that you want to leverage this format string. And then we know that for format string, the way that works is that starting from the 6th argument, right? The 6th argument, it will take stack, read the stack, or like take stacks as the 6th and ongoing, like so on and so forth arguments, right? And because of that, the nice thing is that we can take advantage of that read, starting from here and read all the way down to this place where it stores saved RIP, right? Basically, we tell printf that treat this as an argument, and I want the value printed out for me. Okay, so this is the way that you can use arbitrary read to output the value that is currently stored at this particular location. Okay, does it make sense? Is there any questions? Yes.
Why we are using single RT here? I think previously we are using the RT below single R.
We always use the saved RIP. Like the saved RIP means that this is the location that stores the returned, instruction.
Did we use RBP possibly in the
Yes, I mean, oh, sorry, you're right. I mean, this is not accurate. This is what I mean. Like at RBP plus 8, here is the saved RIP, and here is actually saved RBP. Yeah. Thank you for correcting me. Yeah, so saved RIP is always at RBP plus 8, not RBP. Okay. All right, good. So now we have like a high level goal. What we want to do is to figure this location and then compute the index, if for printf, if they treat this entire thing, as part of their argument. Okay, and then let's try this. And in order to understand, like, where is the RIP, and where is the RSP, and where is the the currently saved RIP's address? It's the most straightforward way is that you debug this program directly. Now just run it, debug it, set it at the place that the printf is supposed to work, understand where is the buffer, where is the argument, so that we can compute this offset directly. Does it make sense? Okay, let's do this together. But if you want to do it by yourself, feel free. I mean, if you think that you can do it, I will be more than happy to see you do that by yourself. And this will be, recorded anyway. So you can also just look back later. All right, cool. Okay, so now let's try. One second. All right. So what I am going to do is that the first thing is that I want to figure out where is printf. So what I could do is I can have objdump and then figure it out inside function func and where is the instruction that's about to call printf. If I can find it, okay, it's somewhere down. I'm just like browsing it very quick to find the string called printf. I can also, it's here. I can also just like search it, but like this is the place that do printf, okay? All right. And alternatively, what you could also do is that you just GDB baby format level 2 directly, okay? Okay, and then you do disassemble func. And then you can find the place that is about to printf. Okay, this is the location, right? So that's func plus 568. And then you can set a breakpoint there. 568. Okay, good. And now we're gonna start to run it. Okay, we run it. They ask you to input something, of course, because this is before printf, right? I'm gonna just put some, actually, let me put some more identifiable string. Okay, cool. And now we're about to do printf, right? Okay, so now we need to figure out, where are the current format string is at, okay? And according to Access 664 ABI, you know that the argument, which is the format strings, right? The address of the format string will be stored at variable RDI. Okay. So this is the format string's address, if you remember, right? So, and then we can take a look at that. Okay. So this is the format string, basically. So it has your input is, there is a lot of, you know, space, and then there is a \n, and then for 10 times of A, this is what I typed here, right? And then followed by \n. So this is like the end line. Okay. So you see that here, which is different from the last time's lab, is that this format string has some prefix. So it's like, it's not start with what I give to them. It starts with some other, you know, a prefix, a constant prefix that has been preset in the source code in the program. Okay. But then still, you know, where is the start of your, you know, the buffer, because you have the value of RDI. And then the next thing we're going to do is you want to parse the current stack. You want to know where is the start of your stack. Okay. So what you could do is that you just print the current value of RSP. So this is the start of your RSP. Sorry, this is the bottom of your stack. So this is the value of RSP, right? So let's write down this value. So that's 8. I'm gonna just write down the last 3 bytes, because that should be enough. You know, because of SLR, all the rest, the starting part, the several bytes, it's gonna be changing all the time, but we don't really care, because all we care about is the offset, right? Okay, so I'm gonna just write the value, which is 861700. 861700 at this is access. Okay. Cool. Okay, so we know that this is the current value of RSP. And let's take a look at the current, you know, address of saved RIP. You could do either just RBP plus 8, or you could use info frame to get the current value, like where is the saved RIP at, right? It should be the same, right? It's the same. Okay, so that is X A6 1D08, right? Cool. Okay, so now you know the offset, the difference between RSP and RBP plus 8. And then now you know that, consider you're doing printf right now. And then printf will treat the bottom here, right, as the 6th argument. Right? If you remember, last time we talked about how x64's calling convention works, starting from, you know, the 7th argument in the function, which is going to be the 6th argument for format string. They will start to parse stack, right? Okay, so now the question for you, this, you know, converts to a simple math question. If we know that the 6th argument is at this location, which argument will be on this location? Does it make sense? No? Want me to explain this again? Yes? Okay, yeah. So if you remember, like, can you tell me if you can remember this, which is fine. I just want to know, like, last time when we talked about printf, we mentioned about like arguments, right? We talk about where are those arguments from printf. So it's like for printf, the first argument, which is the format string, right? And that will be in RDI, right? And then the followed by that will be RSI. And then I think it's RDX and some more. I think it's R7, R8, R9. But then after that, for the next argument will be at RSP, the like stack, the bottom of the stack. this location, right? And then the next will be RSP plus 8, so on and so forth, right? And then this is the format string. And then this is the first argument of like to be printed argument, the first to be printed argument. Does it make sense? Good. Okay, awesome. And then this is the second, third, fourth, fifth, sixth. So that's why I was saying that now the sixth to be printed argument will be at RSP. Okay. And then the seventh will be at RSP plus 8, so on and so forth. And 2, you find the RBP plus 8. So now the question is that we know that the sixth argument is at RSP, right? It's the bottom of the stack, which is this location. Then which argument will be on here? What is the index of the to be printed argument for this particular address? Exactly. Exactly. That's what you need to do. Okay. Awesome. Okay. Now let's do this simple math. That should be what I have here is 198. But let's calculate this together. A6 1 D 08 86 1700. Okay. Okay. And okay, so that's 199. Okay, so that's 199, so that we will be able to get the value of, say, the R. Oh, because here. Because we know that this will start, this is the start of this is the 600. Yes, we're doing this for format string. So basically we're saying that this is the value that we should specify for format string, ask him to print the 199th argument. Okay. Exactly, exactly. This is the arguments that we were supposed to pass to format string. Okay. Good. Okay, cool. So that in this case, you should be able to leak the current return address. Okay. All right, I'm gonna give you guys some time to work on this. Let's say 5 minutes. Okay. Raise your hand if you managed to link your return address. Good. Awesome. So we have some of us that managed to link it. So let's do this real quick because now we already know the AVAX. All we need to know, which is 199, right? All we need to do is to write the proper format tree, which is straightforward because that means that we want to let the printf to print that 199th argument. That's it, right? So what you should do is to have, if you remember last time, we have percentage, right? And then that's the position. And then dollar, right? And then that's the less, like the format. And then in this case, we know position is 199. So that is $199, right? And the format, we're going to print it out. So we want to also print it in, we can print it in decimal, but I prefer it printed into a hex mode because that would be easier for me to plot. So I'm gonna have L X. And that's it's very straightforward, right? As long as you have the 199, you have that position. This is rather straightforward. Just like print it, like this tells you the what is called this is called length. I forgot the name, but you can check that from the slide. I think it's called length variable. Yes. Question. Yeah, good question. What if we put P? So if we put P here, it means that I want to output this value as a pointer. So it should be printed the same way as LMAX. So it's it treated as a pointer, and in this case, it's exactly what we want. Good. This is a good question. Okay, so now we have the return address, right? Good. And then, but then we need to make sure that this is the return address, but this is not the wing function. So there's still one step away, which is that you want to calculate the offset exactly, which is always going to be constant, right? The offset will not change over process, right? So check that return. I'm gonna run my code here real quick. Okay. Okay. So this is the leaked return address that I have from here. And then this is not exactly a wing function, but you can calculate the offset. In this case, what you could do is that, okay, let's say that, let's do op sum. This can be, okay, so this is the wing function that calls func. I'm trying to find, sorry, not wing. It's main function where it calls func, right? Okay, here. Hit. So 1735 is the return, which in the runtime is this guy, is C735. But then you also know that the current wing function is at 1330, right? So all you need to do is that you have that linked return address, right? I'm gonna just do that. Okay, that's that, right? And then minus that hex 1735, and then plus that hex 1330, and this should be the runtime wing function address. Okay. Does it make sense? Going to expand this again? Good. Okay, cool. Now we have the wing, where wing at. But then we need to tackle the next question, which is where that we're gonna overwrite this win function, right? We want to overwrite the saved RIP with the win function. Now we know the value of this guy, right? But then how to overwrite this location with this value? Does it make sense? Good? Okay, so now we can figure out how we can overwrite this place, this value. And then, and 2 weeks ago's lab, we mentioned about, format string, we can do arbitrary write, right? Using the %n. I'm gonna raise this part, okay? If you already good, okay, I'm gonna raise it. So here the goal for us is to use %n to overwrite this with this, right? But then last time, if you remember, we have %n. And what it means is that it will look at the associated argument, right? With this %n, and then parse that value as a pointer, right? Read that value, take that as an address to write to that address, right? So that means that in order to overwrite this place with we have to know where is this. We have to know the value, that we have to know the address, absolute address of this place, so that we can pass that as part of the argument to %n, right? So this comes to the second arbitrary read challenge for you guys, which is how can we get the current RBPs, like how can we get the address of saved RIP using the arbitrary read functionality? Well, we read the value stored here, but we don't read the address. Does it make sense? We need to read the stack address. We need to pick the current stack address, right? Good, make sense? Do I need to extend again? No, good. Okay, cool. So now the question is that since we have this arbitrary, superpower, where on the stack that stores some value related to stack? Yes, save the RBP. So now you need to do arbitrary read again to link the value of here, which is save the RBP. Does it make sense? Good. Cool. Okay. Then we already know that this place is the 199 argument. Then this, exactly, this must be 198. Okay. Cool. So now we should be able to use arbitrary read to get both values. Good. Cool. Okay. I will give you 2 minutes to make this happen. All right. Yeah. Okay. Yes, you can run terminal. I mean, let me see. So there are 2 options that you can do it. One is that here, and there's Ender workspace, and there is terminal. I think this is like, can I run, sorry, can you say it again? Yeah. Yeah, I mean, if you're saying, like, to me, what I did is like I have this my own solution folder, and then inside that I just specify the run to, /challenge. That is what I did. Is that your question? Oh, you cannot navigate to the challenge folder. That's weird. So you cannot do that. CD to challenge. Well, I am also a hacker, right? We have the same permission. Oh, you mean in SSH? But I can still also, I mean, like right now, I am not in the challenge folder. I mean, yeah. Okay, cool. Does this solve your problem as well? I mean, you cannot write the challenge. You cannot have a new file in /challenge, but you can create a folder in your home directory. And this is what I did. Like, this is my home directory. Under that, I create a folder and I put my solutions there. Right, you cannot do that because of the permission. You cannot move the challenge. Okay, where am I now? Okay. Yeah, so should be straightforward for you. All I need to do is just change here a little bit. Okay. So these two are the leaked values, right? So you should also have something similar to this. So one is the stack address and the other is an instructions address, right? Okay, cool. So keep in mind that still, this is not our target destination. This is just a saved RBP, which is a value that is relevant to the current RBP update, right? Because keep in mind that this is saved RBP. This is the RBP that is for the main, like for the caller function, not the current function. But we want to know the actual RBP of the current function, right? Fortunately, there's still the constant, like the offset between these two values is not going to change over the process. So what you need to do is that you have this value, and then you want to get the value of, that RBP. You just debug the program and then check the value there, right? And then you calculate the offset, and then you will using that offset all the time so that you can get the current RBP's value during the runtime. Okay. Good. Okay. So now let's say that we're already done with this. We already know the address. We also know the value that we want to put. And now is the time for us to construct the arbitrary right, so that we can start to overwrite. We can write that to the right place, okay? Okay, so now the question is, we need to kind of do this parsing again, given that we know the format string is somewhere on the stack, right? If you remember last time we did something similar, right? We try to calculate, like try to find a comfortable spot that will store the address, like that we want to put, like which is gonna be the value that it's gonna be like somewhere here on the stack, and then the value will be RBP plus 8, right? This is gonna be the value, which is gonna somewhere from the first part that we passed, right? Okay, but then we also want to find the position, like the index of this specific argument in terms of print f. Does it make sense? So that we can do the arbitrary right. Okay, and now we know what we need to figure it out is that we want to find where is the format string start from, and then where we're gonna put this value, and then we compute difference between here and that, and the RSP, which is the offset, so that we can get the numbers of the index of the argument for print f. Okay, so let's try to do that together. Okay. So what I am going to do is I will, let me think about that. Okay, so let's run the program. Set the breakpoint. Which is right before we do printf, so that is func 586. Okay, and then we'll run the program. A is there. It's 568. Did I put something wrong? Yeah, that's 5. Okay. All right, that should be right before print. Okay, cool. Awesome. So again, so now let's look at where is the format string start from. Okay. So we have XS, RDX, RDI, sorry, that's supposed to be the first argument. Right, okay. So this is the address of the format string, right? Let me write this down. So that is A160. Now this is 8160. Right? Okay, and then let's see where is the RSP. Where's the bottom of the stack? And also let's check where is the RBP. Well, actually, we don't really need that. Yeah, no, we don't need that. We just need the RSP's value. So that is 9F80. Okay. So RSP, this is 9F80. Okay. Okay. So we know that the format string starts at this location, and that is the bottom of the stack, right? And then we want to, now we know the overwritten, like the destination, the address, it should be somewhere in the format string. And then, but the format string will start with like your input is, right? Followed by many space, and followed by some, like the prefix. So we know that the first part, like, all we can control is starting from A's, and that will be already like this location, format string times the length of your input is, and then plus that, a lot of spaces. So the actual address that we can start to control, like the actual starting address that we can start to put our format string would be this location plus the length of your input is, can somebody count how many characters is that? That is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's 14 characters. Right? And then that's 107 times of space. And then 1, because that new line character. And then coming out this together, this is 122. Okay. So starting from this plus 122 is the place that we can put our stuff there, right? Okay, so now the question is, where can we put the actual value that we want to overwrite? And then in terms of printf, which argument is that, right? So if you remember last time, we talked about this whole thing, right? So we know that this is not at 80, and then it will go beyond to that place. So we need to figure out the address. We need to figure out how many paddings, how many bytes are we gonna put there, if there are any requirement for the paddings or not. Okay. All right, so let's try to do this together. Let's figure out how many bytes that is starting from here to that actual place that we can put our AAA or our format strings. And that will be, let's do this calculation, do this math. So that will be this 8160 plus 122, and then minus 9F80, right? That's the number of bytes that will be ahead of our format string, which is 0 minus okay, so that is 602. And then after that will be the format string that we want to specify. And remember, the format string will be starting from, we want to first print some values before that, like some characters, right? Well, actually, let me just print some number of bytes so that this will be equal to the wing function's value, right? Right. And then we're going to specify the current argument, right? And this is going to be LNX, or LX. Is that we want to output some number of bytes before we write this value to that specific location, right? Okay, and then putting this and then that combined together, we need to be able to calculate which position that we want to put, right? So now we know that before this wing, we already output some values, which is where input is, repeated that. So that is 122 bytes. So that means that we need to print some more bytes, right? Which is gonna be the wing's address minus that 122. And then we're gonna specify the values there. Okay. Oh, because 122 is those bytes that you will print for printf. Yeah, because if you remember, in order to use that %n, you need to make sure that those bytes, like in order to use %n, you need to first print some numbers of bytes. And that number will be the value that will be stored in your destination address, right? And then to print that exact amount of bytes, which is gonna be the address of the wing function, right? Okay, so then you need to calculate that so that you can get the string value, and then follow that will be the position, and then the number of the format, the specifiers. Okay. Check it. When is the what sign again? 107. Oh, it's the repeated, like the spaces. Because in this specific challenge, the format string will have a prefix. So instead of only having the user's part, it will also have the prefix, which is your input is followed by 107 times of, space. Exactly. All right. Okay. Yeah, so this is the challenge. I am not going to give you the entire code, but I suppose that this should be good enough for you to understand, like, this challenge is one of the toughest one. It has like 3 parts. You need to leak the address of the stack, you need to leak the address of the wing, and then take advantage of arbitrary right to do this overrating. Yes.
Position refers to where we are going to write that down,
That's right.
which is going to be 199.
No, not really, because here you want to, this position should go to the place that format string that is controlled, which contains the address. Because this is like, when you do arbitrary write is different from arbitrary read, in the sense that arbitrary read will just directly go to that address and then like read that value out. But then for arbitrary write, what it does then is goes to that address and then gets this value out, treats this value as an address, and then writes to that value. Like, for example, here, if it has RVP times plus 8, and then if the %n is associated with this location, then what it does is that it takes this value out, which is RVP times 8 plus 8, and then writes to this location as some value that you specify. So if you are using, say, 199, that means that it will go to here. And then 190, well, actually 199 is here. Right? And then what it does is it takes this value out, which is the saved RIP's value, which is the instruction's address, right? And then it will try to overwrite that address point to where the address that points to, which is to overwrite the instruction record. Because this is like one more layer of the reference. Does it make sense? So yeah, let me say that again. So when you do read, it just say 199. Let's just always just use 199 as an example right now. So if you're doing arbitrary read, then it goes here, you just read this value out, right? But then if it's gonna do a arbitrary write, then it goes here, it gets this value, and then it will write to this value's address instead of this place. Does that make sense? It's like they treat this as a different type, basically. Arbitrary read, they just read it as a value, but arbitrary write will take this as a pointer and then write to this arbitrary, this place's pointer, where that points to.
The position is the RBP plus data.
The position in for arbitrary right? No, not,
Position would be a RSP.
what do you mean by the position is already? So,
POS. The POS.
Yes. yes,
So what is that? Is it the RBP plus data? No.
No, no.
That would be like, this would just be the RSP.
right, so what you need to do is that you need to like have this value, put that somewhere on the stack, right? And then you want to figure it out this location. Having this, the offset between this location and the RSP. And then, do that like, over 8 and then times 6 so that you can get the location. Because now the goal for you is to overwrite, like get this value out, which is RBP plus 8, and then dereference this value, which will be this location. Because for %n, what it does is that it treats the associated argument as a pointer, and then write to the point, right? Yeah, instead of like write to that location, right? It makes sense. So that's why we need this value of RBP, so that when we have the format string, we can put RBP plus 8, this absolute address, this pointer style. Does that make sense?
So does it mean that the format, like, I would you write at RDN? Starting RDN? Starting the address for the RDN?
Yes, start with the address stored on that RDN, exactly.
And what is the LX for that?
So speaking, what is,
The LX for N?
oh, this? So this is the format that specify that I want to write, I want to specify the format, which is, sorry, I want to specify that this is arbitrary, this is a write, like %n, and then this part is the format. I want to write this in a hex format. It doesn't really matter. You can do hex, you can do decimal, it doesn't matter. And then this specify the length. I want to write like 8 bytes in this case. But actually, you don't have to, actually in this specific challenge, you don't want to write this long. You may also only want to write the less than 2 bytes or even less than 1 byte for that specific address. So you need to tweak the specifier. In the slide, I already have this part, right? If you look at the slide, I have one page that talks about the specifier. Then what are the meanings of it?
Is it an L or is it one?
L. This is L, X, like long, hex, and the %n.
Why do we need to do the calculation for the particular?
Yeah, this.
Yeah.
Because you need to know, starting from there to this particular location where you're gonna specify the destination, the target address. You wanna look at this offset. That's why you want to calculate that 602 so that you can know where is the start that you can specify your format string.
Do we need to make sure it's very heavy to like, it's multiply.
Multiply.
I mean,
Uh-huh.
to that we have to start from something like 0, 8, 16.
Yes, yes, you need to consider that, but that is after the 602 bytes. Because like these are similar to what we did the last time in the lab. It's like you specify how many bytes that you want output, right? That's the 0 something, right? Like you had some value. Okay. All right, so that's pretty much for today's lab. Not really lab. I mean, this is just one of our challenge. And yeah, I will see you guys next week.